Okay, everybody, welcome back, my friends. Let's go ahead and continue our journey here in learning more about Leptos and Rust along the way. So, if you remember before the lunch break, we were taking a look at parent-child components. We were taking a look at how we could pass data, but also functions or update functionality from a parent component to a child. We explored how we could use the read signal and write signal as parameters to the child component, which would allow the child to update the data. And that worked well enough, like it updated everything and everything stayed in sync. Hold on one second, let me restart my code space here. It looked like it was working, but I guess it wasn't. Anyways, we had the ability to pass the read signal and the write signal down. The problem is that passing the write signal into the component basically allowed the child to modify it however it wanted to. And so we were basically discussing the fact that this is probably not the best way to do things. It's probably better to control the logic of how we do the updating in the parent and then pass these functions into the child. And that's what we're going to set up here, is we're going to set this up so that we can pass these functions into the child component. So what I'm going to do is come into here and I'm going to create a new component for the child. So go ahead and set up our new component here. And for the parameters to the child, they're going to be a little bit different. First, we're going to keep passing in the read signal for the counter. So receiving the read signal isn't a problem, right? Because all it does is basically just subscribe to the counter value, and then when it updates the UI. That's fine. But what we want to do is control that logic of how the counter is updated, control that in the parent, and then pass functions down to the child. And we're going to do that by doing the following. We're going to say prop into on increment callback mouse event. I'll go ahead and pull in the mouse event there. And then we'll have another one of these prop into on decrement callback mouse event. So the mouse event is that event object that's triggered by the button. So you can imagine that inside of the child here, we're going to have a button that we're going to connect this function into. And so when that function is called, it will be supplying a mouse event. You'll notice that we have an into here on our prop. In Rust, there is a mechanism called into and from. So there's the into trait and the from trait. And basically the way that works is that if a type implements the from trait, you can basically take some other data type, assign that to the thing that implements the from trait, and it'll automatically convert it using the from trait into the target type. So you have a from trait that's able to receive a source type and translate it or convert it into the target type. In this case here, what I want to do is I want to take this closure and have it converted into a callback. And so we're going to be able to do that through prop into. Prop into can receive these closures and convert them into the callback type that you see listed here. Now, what I'm going to do is I'm going to grab this view block and I'm going to drop this into the child. And I'm going to modify this to say child callback. And then I'm going to take the on decrement or on increment and assign it here, and take the on decrement and assign it here. So notice I'm not creating, as we did earlier, I'm not creating more functions and assigning them. I'm receiving the closures that we're going to pass in from down here. They're being converted into these callback types, and then I'm going to assign them here like this. So go ahead and copy that up, and don't forget, you can get rid of the extra div on the extra div wrapper when you copy that up. So I'll pause for a second, let you go ahead and update your child component. And then we'll scroll down to the parent and we'll call that child component. Give you another 30 seconds. Okay. Now, let's call the child component from down here. So we'll come into here and we'll say child, and then we'll have counter equal to counter, on increment equal to increment counter, and on decrement equal to decrement counter. I'll put that on multiple lines. And so now I'm taking those, well, I tried to reformatted that. That's okay. So now I'm taking those same increment and decrement functions we created on 31 and 32. Not only can I pass them directly into the button, but I can now pass them directly into my child component. And now I'm controlling that logic here in the parent component. So go ahead and wire that up. I'll let you run the code here real quick. I'll run my code in a moment. And then after we run that, we're going to take a look at the third example. So the advantage to this one was that we can control the logic in the parent. Okay, I'll go ahead and run my code. All right, let it finish compiling. Okay, so now if I come back over here and refresh this, let me click open in browser. Okay, great. Parent child, callback, same results as before, but I have better control over where my logic is. And yes, I can scroll back into the into part, absolutely. This part right here. And I'll go ahead also too. And I pushed my code up as well. Give you another minute, and then we'll take a look at the third little demo for this. All right, another 30 seconds. Looks like we have a question here. Let me see. The Q&A is a little slow to load up here for me. So if you just put a question in the Q&A, it's trying to load the Q&A. Okay. Let's go ahead and take a look at a third mechanism. The third mechanism is really just an alternative to the callback. It still accomplishes the same goal as the callback, but with a different kind of syntax. It's actually a little bit messier, but I think I want to show it to you because it does make use of generics and some lifetime stuff as an alternative to using the callback type. So let's repeat our process here one more time. Inside of our parent-child folder, we'll create a new file. And we're going to call this parent-child closure instead of callback. And I'll make that wider here in a second. So the name of the file is parent-child closure instead of callback. So we're going to do something similar to what we did with the callback, but instead of using callbacks, we're just going to stick with plain closures. And you'll see some of the extra work that kind of has to be done here. All right. So once you have that file created, if you want to go ahead and do all the basics to get it fully registered, feel free to do so. If you don't remember all the steps, I'm going to walk through them now. So the first thing I'm going to do is come in and say component. Well, let me do my use Leptos first. There we go. Then public function parent into or impl into view. Then we'll have our view say parent child closure instead of callback. And we'll close that off. Quote there. Quote there. So go ahead and add that initial component. Okay. Now I'll need to come over to mod and do the pub mod parent child closure. Also, what I'm going to do is while we're in this folder still, I'll go ahead and update this to have the third link. So we'll just say closure instead of callback. Closure instead of callback. So that'll be demo, the third little demo. I'll pause for a second while you update your mod and your parent-child home. Remember, we don't have to update the mod for components, and we don't have to update lib, but we do have to update app to pull in the new component and then to reference it as part of the routing mechanism. Give you another 20 seconds. All right, cool. I'm going to go ahead now and go over to app. Up here at the top, I'm going to say parent, child, parent as parent closure instead of callback, like that. So go ahead and bring in that component. And the Q&A is not currently loading for me. Let me try again. Now it's popping back up. All right, so I'm got a borrow error when adding counter to child component and parent. Is that normal? Okay, cool. You got it figured out. Awesome. Great job. Okay. All right, so now what we're going to do is we're going to come down to here and we'll add in a new route path equal closure instead of callback. Go ahead and add that route for me. If you specified shorter names for things, make sure you use the shorter names that you specified. Okay, so now that we have that configured, if you want to go ahead and run your code, make sure you can load that third demo component up, and then we're going to go and do some coding over in the third demo. Okay, so I'm going to open up the parent-child closure instead of callback. And remember the parent-child callback that we had before this one here? I want you to copy this whole component, and I want you to replace the parent here, and then we'll go ahead and start working on the child. Okay, so I copied this code. From the callback demonstration. I copied the parent code from the callback demonstration, and then I added this piece of code up here, and we're going to implement a new child using a closure instead of a callback. Okay, so first of all, let's define our first parameter. Once again, it will be a counter read signal, and in our case, it's an I16. So go ahead, add counter read signal to the component parameters. Now, instead of using the callback type, we are instead going to use generics in Rust to specify the type here for the increment and decrement button. So on your child function definition, type in increment button and decrement button like that. So this is going to be the type definition. So these are type parameters, generics, right? Remember in Rust, all the generics are monomorphized into specific function implementations for the different combinations of generic types that you use. So there's our increment button and our decrement button. We're going to come down into the parameter list. And we're going to say on increment button, on decrement button. So go ahead and specify our parameters there. And then we're going to have to set up a generic type constraint. So we'll have a where block. I'll wait for a second while you add those, and then we'll add the where block. Okay. For our type constraints, we're going to say increment button, and it will be a function that receives a mouse event as the parameter type. We'll need to pull in mouse event again. And it will also be static. And we'll repeat the same thing down here for decrement button. Now, this is where things in Rust start to get complicated. When we start bringing in lifetimes, what exactly is a lifetime? Ordinarily, when Rust compiles your code and looks at how you're using your variables and the data that those variables point to, usually it can figure out how long data is supposed to live. So for example, if a function owns some data, when the function starts, it creates the data. When the function exits, the data is destroyed. Rust knows the lifetime of that data. If you have a function where you pass it some data and the receiving function takes ownership, when that receiving function exits, the data is destroyed. Okay? If you pass a reference to something, you hold on to the reference in that function you called, but then when the function returns, that reference is in a sense returned back to you. And so you can do what you want. Rust understands the lifetime of that. However, there are times when things are created, maybe two things that are created independent of each other. But one of those things needs to use that other thing. Rust needs a way of knowing if that other thing is still going to be around when we go to make use of it. Okay? So here we're creating these functions on the outside. All right, and we're passing these functions into the onClick here. We're passing the functions into the child here. We're going to pass these functions directly into the child here. The child needs to know that for as long as the child is around, these functions are going to be around. So essentially, we're requiring these functions to be static. So they'll always be present. So we'll come into here, and we're going to copy our code here again. Paste that into here. Don't forget our view macro. I'll replace parent with child. And I'll grab the on increment instead of the increment counter, and the on decrement instead of the decrement counter. Whoops, there we go. All right, so now instead of having the callback type, I'm using generics here to be able to receive my function and then be able to call it here. An alternative way of kind of accomplishing the same thing that the callback did for us earlier. So this was our callback mechanism. All right. And you can see here where it's handling that static lifetime. And if we go to definition. All right. Let's take a look here at the callback versus the generic. In the chat, can anybody tell me, looking at this code and looking at this code, what the difference is between the callback versus using the generic. What's the fundamental difference? I'll give you a minute or two to put an answer in the chat. What's the fundamental difference? Excellent job, everybody. Yes, that's the big difference. You'll see here, we're using box dyn. Anytime you see box dyn in a Rust application, that means we're pushing something out to the heap. And it's generally going to involve some type of dynamic dispatch in order to get to it. It's basically not a zero cost abstraction. There's some overhead associated with doing this, and there's also the actual act of going out to the heap. One of the things you'll find in Rust is we always make this effort to push things back to the stack. It doesn't mean you'll never use the heap. You use the heap all the time, but especially in situations like this, if I want to get that zero cost abstraction, I'm going to want to push things back over to the stack. Here's our problem. And let me see if I can kind of explain this within our time that we have here. We go over this in a regular Rust class, but here I'll give you a quick summary. When you look at these two functions, you might think that these two functions have the same type definition. They both receive a mouse event, and they both output nothing. Actually, they don't have the same type definition. In Rust, every function is its own unique type. Every function is its own unique type. You'll notice up here that when we go to pass this function in, we're using traits to pass the function in. We're not using like a function type definition. We're using traits. Traits and types are not quite the same thing. You could kind of think of a trait as more like an interface, kind of. Anyways, you'll notice we're using traits here, not type definitions. Over here, we're using a type definition. In order for this type definition to work with all functions that receive a mouse event and return nothing, that's going to have to be pushed out to the heap because every function has its own type. If you don't know what the type is at compile time, then you have to push it out to the heap and do a box dyn with it and resolve it at runtime. However, if you use a generic and let each function have its own type and apply that to the generic, you get the zero cost abstraction because Rust at compilation will produce a function that's customized to these two functions being passed in as their own unique special types. The downside, though, is if you call this child from multiple places with different functions, you're going to get this same component repeated over and over and over and over again in the source code because each of those functions will have a different type. Zero cost abstraction, but larger executable. The problem is that larger executable has to be downloaded to the browser. On a server app or a desktop app, the larger executable is not a big deal. But in a web app for WASM, it can be a big deal, right? If you have a large application and you're recreating all these generic functions over and over and over again to avoid the heap, that might not be the better way to do it. So a technique that I might use for a desktop app, like preferring generics over box dyeing, I might not prefer that in a WebAssembly app that has to be downloaded. So this keeps everything on the stack, and everything is known at compile time, and it will even execute a little faster, but it results in a larger WASM file. This doesn't know the size of everything at compile time. It forces us to use the heap. The dynamic dispatch is slightly slower, but my WASM file should be a little smaller because I can use one component using the callback over and over and over again, and I don't have to monomorphize like I'm going to have to monomorphize here. A lot of people don't realize that functions, each function definition is its own unique type. It's not like other languages where you can say, oh, this is a function that receives this and returns that, and it's like one type definition on the stack. If you want to do something like that, it ends up becoming this on the heap. But in Rust, you can specify kind of a function definition through the use of traits, but that's now going to bring into the mix generics, which is then going to cause my code base to be bigger. Raise your hand if that kind of makes sense. It's a complex thing. Okay, it's a complex thing. But this is about the trade-off you make thinking about a server or desktop app relative to a WebAssembly app. Okay, generally I would prefer the generics, and I like to avoid the box dyn and the dynamic dispatch. For a web app though, I might be okay with this because I don't have to have 20 copies of this component in my code base because of all the monomorphizing. Anyways, two different ways to approach this particular problem. If we can push stuff back to the stack, we avoid the heap and the dynamic dispatch, but we have more code. We push things out to the heap, we have less code, but we have then the heap being used, dynamic dispatch being used. That's the trade-off. And it's all about knowing the type at compile time. So in the case with generics, I know the type at compile time. In the case of the callback here, I don't know the type at compile time, so it's going to get pushed out to the heap. Pretty interesting, huh? So one of the things I'd recommend you do, like when you come across something like this, especially if you're first learning Rust and you're really trying to go deeper in your understanding of memory, if you see something like this, take the time to look up this type here or whatever that type is in the thing you're working on, and take a look at its definition and see if it doesn't move to the heap because it's not going to know that function type at development time. All right, cool. So there you go. So there's our difference between those. So the reason we went through this whole process was I wanted you to see some of the basics of working with signals, passing things down from a parent component to a child component. And I wanted you to see what different strategies for doing that, and then what it looked like for things to update. If we had more time, there's lots of other things I would go over, but this is enough to kind of help you start to see what it would look like to start to build your own component tree and have some data on it, respond to user interactions, stuff like that. What I want to do now is I want us to switch over to the color tool application, and we're going to add the color tool piece to this. Okay. For some of this, we'll copy from Tools App Final. For other parts of it, we'll do the live coding. But let's start first by wiring up the initial component folders in component and getting it all wired up into app. And let's put that together here real quick. So underneath the components folder, let's create a new folder called color tool. I'd like you to create a new file called colorhome.rs. Go ahead and do your use Leptos, you're also welcome to copy from another file if you'd like. Okay, so go ahead and wire up color home. Don't forget, inside of color tool, you'll need to add a mod RS file. And we'll say pub mod color home. I'll pause for a second while you do that. We'll also, in this case, need to update the components mod file. We'll need to update librs and then update the routing system to load up color home. Now, let's come into component mod rs and let's say pub mod color tool. And then let's come into the librs and say pub. Actually, pub mod components is already there. We don't have to pull that in again. I take that back. So yeah, go ahead and set that up. So color tool on the components mod rs. And then we'll come into here and we'll update the app rs. So for this, we're going to say use create components, color tool, color home. Go ahead and import that for me. Okay, next step. After I import that crate up here, I'm going to want to come down to here and add a menu item for color tool. So go ahead and add a menu item. It's color dash tool and then color tool. So go ahead and wire that up. And then we'll update the routing down below. So I'll come down to the routing. It'll be color home and color tool. So essentially what we're going to do here is we're going to build a list of colors that we'll be able to add to and delete from. And it will be add to and delete from a database, a SQLite database. So it'll be a full stack application. All right. So go ahead and run your code and make sure that you can view color home. All right, looks like it gave us it looks like it started a new recording. I guess what it's been, 4 hours. So every 4 hours we get a new recording, I suppose. So if you want to try to download that, you can. I'm not sure if you have permissions or not to do that. But I'll take the first recording and the second recording and put them together as a single recording that I'll send out to everybody later on today or tomorrow. Okay, so now that we've got the routing in place, let me go ahead and run my code and make sure it loads for me. So cargo, Leptos, serve. And then we'll come into here. I'm going to refresh. And I have color tool now listed there. Okay, cool. So there's our color tool page. Now, before we build any more UI stuff, let's take care of a couple of data things in our project. How does that sound? So what I'd like us to do is the following. In our source folder, let's create a new folder called models. In our models folder, we're going to create a file called color.rs. And we're going to pull in some stuff. We're going to define the model here for working with our color. So we'll say use Serde, deserialize, and serialize. Go ahead and pull that in. The object relational mapper that we're using is called SQLX. And we need that object relational mapper for the server side code. We don't need it for the client side code because the client side code can't talk to the database. But I don't want to have to write my color model twice. I want to write it once so I can use it on server side and write it and then also be able to recompile it and use it for client side. So the way we're going to do that is I'm going to come into here and say CFG. And we're going to do feature equal server side rendering. And if we are doing server side rendering, we'll bring in SQLX from row. Now let me talk about this here real quick. When we compile the Leptos application, we actually compile it twice. The main RS produces the actual executable that runs on the server. The libRS is the library for the WebAssembly that runs up in the web browser, right? So obviously with main RS, I wouldn't be running the web server in the web browser, right? But the libRS, this is what's available to us in the web browser to bring all these components and stuff like that together. So when I go to create my model here, I need to tell it that when I'm compiling it for the server application, I want it to bring in the object relational mapper, the SQLX. It's not even really an object relational mapper. It's really just a SQL connection mechanism that provides some functionality for migrations and things like that. However, when I compile the code for the WebAssembly in the browser, I don't want to bring in the SQLX because it's not going to be able to do anything for me in the browser. The browser code can't directly talk to the database. All the browser code can do is call back to the web server through HTTP to get the data. And Leptos is going to manage all that for me. But when I go to compile this, I need to say, hey, bring in certain modules for server-side code, bring in certain modules for client-side code, and use these configure macros so that I don't have to write all of that code twice. So we're going to come in here and put another configuration macro for configuration attribute. And we're going to say feature equal SSR. and we're going to say derive from row. So what that means is that if we are compiling the server-side code, we're going to derive from row on the struct that we're about to define. Whether we're server-side or client-side, we're going to derive, serialize, deserialize, debug, and clone for the struct. And we'll say public or pub struct pub ID string, pub name string, and pub hex code string. So if we compile this client side, we'll have a color struct with serialize, deserialize, debug, and clone. If we compile this server side, we'll have a color struct with from row, serialize, deserialize, debug, and clone. This is always one of the challenges, by the way, of doing these isomorphic web apps that can render server side, client side, whatever. Even if you get into something like Next.js and stuff, there's always this code that you have to include that figures out whether the code is running on the server side or client side, and then does slightly different behaviors depending upon its runtime environment for that piece of code. Here we're configuring all of it through these macros that are applied at compile time. All right, I'll give you another second to update that. All right, once you've got that set up, we have to come back into models, create the mod rs file. And we're going to say pub mod color. I'll flip that down. So go ahead and put pub mod color into the mod rs file. You will need to update your lib to pull this in. Okay, cool. So now let's go ahead and open up to the side here the librs, and I'm going to put pub mod models. So go ahead and bring in our models in the librs file. Okay. We're going to need to pull in a few extra crates for all this to work. You'll notice once I tied color RS into the application by wiring up all the mods, we now get the red squiggle saying, hey, we don't have the Surday crate installed, stuff like that. What I'd like everyone to do is go ahead and open up your terminal window. And I'm going to have you install a few things here. So the first one that we're going to do is install Surday. So we're going to do this. We're going to say cargo add surday -f derived. -f is short for -- features. So this will add the surday crate and it will include the derive feature. So notice I'm using add and not install. Cargo install installs utilities on your system. Cargo add adds crates to your projects. So we'll come into here and run this, and you'll see it's going to install that there for me. I'll drop the command here into the chat for you. Okay. Next command we're going to need is cargo add. We're going to install SQLX. We haven't installed that yet. -f runtime Tokyo, comma, SQLite. I'll bring in the SQLite functionality for us. I'll go ahead and run that, and then I'll copy and paste it. And looks like it brought all that in. And I'll copy that command. Whoops. Copy and paste. Make sure you're running all of this from the actual Tools app folder. The next one we're going to need is a UUID crate for creating UUIDs for adding things to SQLite. So for that, we're going to come in and say cargo add UUID. It's almost as bad as JavaScript when it comes to Rust crates. -f and we'll say v4, and that'll install the v4 of the UUID. I'll go ahead and copy that. And I'll paste that for you. And the last one we're going to need is the who am I. So we'll say add who am I -f default. And that should bring in who am I, and I'll drop that into the chat for you. So go ahead and run those to add those crates. So now if you notice here, once you've added those, you'll notice the surday and the SQLX in the color RS file is now happy again. Okay. Next step for us. We need to add a repository. Now, I'm not going to have you type all this out. We don't have time for that. What I am going to do is give you the direct link to Tools app final, where you can access this code. And let me walk you through what we're going to do here. I am going to create, under the source folder, a new folder called repositories. So repositories. Underneath repositories, I'm going to ask you to do the following. If you come over to the Tools app final, you can copy color and mod, just copy those. Scroll up to repositories here and paste them, and then modify the mod. Modify the mod to not have the car repository anymore. So go ahead and copy color repository and the mod from the repositories from the final project. Copy them into a repositories folder under Tools app, and then remove the car repository. Okay. So once you've done that, you've got the repository there. What I'd like you to then do is come over to the lib project, open it to the side, and go ahead and put pub mod repositories like that. So go ahead and bring that in. And that'll light everything up in the color repository file, and you shouldn't have any errors in there. So you're welcome to take a look at that, but there shouldn't be any errors. I'll give you another 30 seconds, and then I'm going to walk you through the repository file real quick. Okay. Let's walk through here and take a quick look at what this is. This is the actual code to talk to our database that we haven't created yet. There's the color model, bringing in Leptos. Configuration for server-side rendering, we're using the Actix web. You can also use Axum. Actix and Axum are both popular server-side frameworks for building web applications in Rust. We have in append color, a remove color, and in all colors. You'll notice it's not really an object relational mapper. It's really just a SQL client that allows us to issue queries against the database and does some basic things like binding parameters for parameterized queries and things like that. Anyways, the database that we're going to be using is SQLite. And you can see I basically just have some SQL statements here. Everything's parameterized, so on and so forth. I can do an insert, a delete, and then I can select the colors as well. Okay. I have this code here to kind of demonstrate what it looks like if an error happens. If we have time, we'll go over that. If we don't, you can always go in and turn that on for yourself and see what it looks like when an error happens when you try to load this from the page. All of this code runs on the server, okay? These are server functions. It's not possible, like I said, for the WebAssembly app to directly talk to the database. In fact, that's actually an area where a lot of people kind of struggle when they start doing WebAssembly type stuff, is they'll think to themselves, well, I'm coding in a server-side language. Can't I do all the regular server-side stuff that I typically do? And the answer to that question is no, you cannot. You can only do the things in the client that you would ordinarily be able to do in the client. You can't do all the other server-side stuff. Even though we're writing the code in Rust, and even though we think of Rust as a server-side language, when it's running in the WebAssembly runtime, you can't do server-side operations. So anyways, all of this code is going to be on the server only for executing our actual database requests against the server. You'll notice it's all asynchronous, getting our connection, executing connections, stuff like that. It's all asynchronous. Okay, so now what we need to do is we need to configure the database piece here in the application to actually connect to the database, run the migrations and stuff like that, because it does provide a migrations API, which is kind of nice. So what we're going to do for this is we're not going to type all this out. This is all just straight up boilerplate configuration type stuff. What we're going to do is we're going to come down to the main RS file here. And what I'd like you to do is You see where we have this use SQL X right here in the main function? So let me actually split this over. And let me close some of these other files real quick. Okay, so we have Leptos, ActicX right here, right? And you'll see there's a use SQL X right here. What I'd like you to do is copy that use SQL X and paste that in like that. So go ahead and copy the use SQL X from here under Tools App Final, copy it over here to the main in our Tools app. Okay, next step. You'll see we have our SQLite pool options in our migration stuff right here. I'd like you to copy those two things and move them over here like this. Now, you'll see the database path here is a little different. The database path is going to go to the Tools app final. Just modify that to be Tools app. So just modify that path there to be Tools app. So copy over the let DB pool and the migrate. This is all just configuration code. Now, you'll notice we have some errors here for the IO. And that's because at the top here, we need to bring in standard IO. So up here at the top of the function, I'll bring in standard IO. Go ahead and bring that in for me. Okay. Go ahead and scroll on down here for me. Now, you see down here where it's got this service files, right underneath the new here for app, you'll notice there's an app data dbpool.clone. Go ahead and copy that and move that over to here like this. We have a red squiggle under the migrate, the migrate macro. We'll take a look at that in a second. But go ahead and copy over the app data here. This will bring in the data as a service for us to use. We should be good on all of that. Okay. Yeah, go ahead and bring in our data there. All right, let's see if we can figure out what's going on here with our macro real quick. I'm sure there's just something I'm forgetting to import in. I have my standard IO, Attix Web, Leptos, all that looks good. SQL X, that looks fine. Tools app star looks fine. Generate route, all of that looks good. And okay, let's mouse over this. Let's see, migration. Oh, no such migrations, file or directory. Oh, we haven't created that yet. Okay, good, that's the issue. What I'd like you to do is underneath the the source folder, actually not the source, underneath the Tools app folder. So not source, but underneath Tools app, create a new folder called migrations. And it should pick that up and be okay. Yeah. Create a folder called migrations right there underneath Tools app. Now, what we're going to do is we're going to take our break. When we come back from our break, we're going to set up our migration and create our database. Once we do that, we'll go ahead and build out the code to display a list of colors. And then we'll add in the other add and remove functionality as part of our final hour together.